Now, let us start with the introduction to Arduino. Now, Arduino is an open source. When we try to talk about open source, it's free. The schematics are free. You know? The coding is free. You download the software, nobody will sue you. Nobody will file a copyright infringement on you. It's because they filed this one as an open source platform. Even though that you get the schematics, you build your own Arduino from scratch from a PCB, no one will actually file a case against you. It's because it's open source. It's free. You may try to utilize this one. Ang pakiusap nga lang kadalasan ni Arduino, if you're making their own circuit, please try to put the Duino, the last 5 letters in the Arduino, and put it on your board. Let's say, for example, in eGizmo, they copied this Arduino microcontroller and they called it as Gizduino. Alexan, another electronic company here in the Philippines, electronic supplier here in the Philippines, they make their Arduino and they name it as Gizduino. So on and so forth. There are so many Arduinos that scattered all over the world, and they try to name it on their own, but they still acknowledge the group of Massimo Bansi. Massimo Bansi is one of the founders of Arduino, and they actually started this one as a project. It's a master's thesis actually that they try to work with. Is because Massimo Bansi find it very difficult for most of the engineers and electronics hobbyists to work on with a PIC microcontroller or a Zilog microcontroller. Those are ancient times, around 2000s. It's very difficult really to program on those kinds of microcontrollers. Why? It's because you need to have a separate board for that to program on the chip. You need to put the chip onto a PCB, and once that you put the chip on the PCB, so many things could work. But if you try to fail on the programming on the chip, you need to replace the chip. Papalitan mo yung chip. You know? That's how Massimo Bansi feels about the technology way back then. You know? I feel that it's because when we try to work on with different types of microcontrollers before during our college days, isa sa pinakamahirap is yung una pag-program is because it's difficult to really program on machine code. For those who know microprocessor systems on their subject, they know what is a machine language. We call it as the assembly language. It's very difficult to program on that. Padalawa, if you got your program wrong and you upload it or you burn it onto the microcontroller, there's a possibility that the microcontroller be damaged and cannot be reprogrammed again. Problema yun. Mura yung microcontroller, mura yung chip, 40 pesos. But during our time, you need to buy the microcontroller where? In Manila, in Visoria. And sometimes it is really we call it as hard to find. And Massimo Bansi found this as difficult and cumbersome for students and hobbyists. So that's why he tries to develop, a group of 5 develop a microcontroller that is easy to use, an open software that anyone could actually use and have fun with it. And the rest is history, I would say. Ang daming naging mga projects and actually products that come from or that started with Arduino. Pebble Watch is one of which. 3D printers, the commercial 3D printers, the first commercial 3D printers made by MakerBot, is actually built in the core of an Arduino. It's the brain of the system. Siya kasi yung pinaka-brain ng 3D printers. If you want to see and you want to make your own 3D printer, DIY 3D printer, you could try to get the schematics of that on MakerBot, if I'm not mistaken. The very first 3D printer. Commercial, it's commercial, yung commercial 3D printers. That is available for consumers. And they call it Arduino in the USA. But in outside USA, they call it as Genuino. So in Asia, here in Asia, ang tawag daw dito is Genuino. But still, we try to adapt pa rin the concept of the word Arduino. When we try to talk about Arduino, kahit ano pa man yan, basta gumana sa Arduino software, we always call this one as Arduino. Moving further, we have lots and lots of Arduino types that is available in the market. China brand man yan, makikita nyo sa Lazada or sa Shopee, down to the official Arduino. Actually, this is outdated already. Some updated has built-in Wi-Fi and Bluetooth already. The Arduino MK100. But these are the things, the basics. Since 2010, these are the basic Arduino microcontrollers that is available up until now in the market. The very famous will be the Arduino Uno. Then we have its bigger brother, the Arduino Mega. Later on, I'll be showing you some of the features of or some of my Arduinos here at home that I'm using in some of my projects, even at school. Wait for a while. Okay. So we have different types of Arduinos and it has its parts. We will be discussing only two of them since this one is the two most popular Arduino boards that is practically available in the market. One is the Arduino Uno, the very famous Arduino Uno. It has its parts here, like the first one is what we call the digital I/O pins. Then number 2 is what we call the pin 13 LED pin, because one pin in the Arduino has a built-in LED which is located at the lower portion of the digital I/O pins. We have the power LED. Isa din yan sa mga indicator natin. Let's say for example, if you want to check if your Arduino, at first, if you want to check if your Arduino is broken or not, the first thing that you need to check is the power LED. The Atmel 80 Mega microcontroller, it's the brain of the Arduino itself, where we try to program our projects, our sketches. Dito natin siya ina-upload at nilalagay. The black one. Analog pins. Later on, we will be discussing what is digital and analog pins. How does it differ? We just try to check first what are the parts and what are the where is it located. Power connector, number 7. If you want to power Arduino separately using an adapter, a charger of a cell phone, you could use the power connector. You have your RX and TX LED indicator. RX and TX means is receive and transmit. So you could see if the Arduino is being linked with either a computer or a Bluetooth using serial connection. That is your receive and transmit indicator. You would see there that would be blinking if it will be transmitting or receiving any data. USB port. USB port is important is because you will be connecting it to your laptop or to your PC so that you could program on the Arduino. And finally, we have the reset button. So those those are the parts of the Arduino Uno. Next one is we have the Arduino Mega, and this is the bigger brother of the Arduino Uno. So you have your digital pins at the top portion. You have also digital pins pa on the right side of the Arduino Mega. You have your analog pins, you have your power pins, LED 13, still we have the LED 13, and you have also the RxTX or the communication LED, USB port, power supply, and it's board way better than the Arduino Uno. When we try to talk about Mega and Uno, what is its difference? Its memory capacity and the number of input-output ports. But please take note, you cannot try to put even an MP3 file or a music file on your Arduino Uno or Mega. Sobrang liit lang ng kanyang memory capacity. Its capacity has only the ability to do very limited function. Not that kind of limitation na sobrang limited. But it doesn't act as a computer. Yun na lang masasabi ko doon. As a personal computer or a laptop. These are some of the specifications of the Arduino. We have the Arduino Uno, Mega, and the Micro. This is the three commonly used microcontrollers. So on the Arduino Uno, kita nyo no, yung flash memory niya kung gaano kaliit. On an Arduino Uno, you have only 32 kilobytes. A laptop holds a terabyte or gigabyte of memory. Ang Arduino Uno only has a kilobyte of memory. And take note of the clock speed. When we try to talk about the clock speed, this is what we call the processor speed. It is only at 16 megahertz. But now we are trying to talk about gigahertz. 5 gigahertz to be the maximum for commercial-based overclock processors like Intel and AMD. But the typical is around 4 gigahertz. Pero si Arduino, nasa 16 megahertz lang. So you cannot actually run an operating system on an Arduino. You cannot put a Windows OS dyan o Linux, hindi pwede. It's because of its limitation. Then you have your voltage level, 5 volts working system. You have USB connectivity, and later on we will be discussing about shield compatibility. Now let me show you some of my actual samples of an Arduino Uno and Mega. Well, I'll try to first get the Arduino Mega. This is an Arduino Mega. If you would be looking at it, and I'm holding it within the palm of my hand, this is how small an Arduino Mega is. I could hold it within the palm of my hand. And again, this has more ports compared to an Arduino Uno. If we're talking about an Arduino Uno, we have also an example here. Well, Arduino Unos, I would say. I put this one on in connection. I have multiple Arduinos. It's because I try to work on with remote laboratory in the electrical engineering department. This is a different one. This is an Arduino compatible board, and it has the size of the Arduino. So if I will be comparing the size of the Uno with the size of the Mega, halos nasa a half or more than a half yung size ni Mega kay Arduino Uno. And it has limited ports sa Arduino Uno. But if you will be working on the basics, if you will be working on the basics of Arduino, then you start with an Arduino Uno for a cheaper one. You could buy an Arduino Uno around 160 pesos to 250 pesos in an online seller, whether that would be Lazada or Shopee. Arduino Mega would price around 280 to 500 pesos. It depends if it would be a China brand or a clone brand, sabi nga natin. But please be careful on buying this on Lazada or Shopee. Please try to take note that some of the clones, I'm still using clones. I'm using clones because the original price of an Arduino Mega is actually around 2,000 pesos, 2,500 to 2,000 pesos. So that is times 10 of what you will be buying if you are buying a clone version, which actually works the same with the original one. But there are some types of Arduinos that you would try to take a look at it. It's because it has a different type of chipset, but it could still work on with the Arduino software. Ang problema lang is you need to install drivers so that you could work on with the Arduino Mega. If you're using we call it as the SMD and the non-SMD one. Just like with this one, you would see, I have a Arduino Mega, two Arduino Mega, and you would notice that the branding is different. Sometimes, if you have this kind of logo or branding on your Arduino Mega clone, you need to install some additional drivers for you to work with this kind of board. But if you have this kind of branding, that has a logo of the Arduino, you don't need any drivers. Just install the Arduino software and you could already work on with your Arduino projects. Doble ingat po if you're buying one. Kasi baka sabihin nyo, ay yun pala, sabi ni Sir Roca, pwede pala kami bumili ng, madali pala makabili ng Arduino Uno or Arduino Mega. Bibili ako ng mas mura. Tapos nung dumating sa inyo, nung kinabit nyo na yung cable ninyo at kinabit nyo sa PC yung Arduino ninyo, sabat hindi makapag-upload ng Arduino program or Arduino sketch, but hindi ako makapag-upload. Hindi ma-detect yung Arduino ko sa laptop ko. It's because there's probably additional drivers that you need to work with or install so that you could work on with your Arduino. So please be careful with that. If you're asking me what are some of the projects that we have made which pertains to Arduino, one of which is a project of mine together with Sir Mark De Vera, our former vice dean, and Engineer Cabrera and Engineer Rojas, our professors at Electrical Engineering Department. We try to work on with this project. If you would notice, sir, wala namang Arduino dyan, ano? Walang Arduino. But since I learned Arduino and I learned the basics of it and I try to expand my knowledge further and try to look at other boards, non-Arduino boards that is compatible with the Arduino software, I'm using right now a ESP8266, a microcontroller Arduino compatible. We call it as Arduino compatible boards that has Wi-Fi built in. So what's cool with that is you could try to control an appliance wirelessly, Wi-Fi, using your Wi-Fi and using your application, and control your appliance at home, and at the same time monitor power consumption, your energy consumption at home. As small as this. As little as this, you could control your lights and fans at home and actually monitor its consumption. And using a Wi-Fi based Arduino compatible boards. That's the good thing about learning Arduino. It's because as you try to expand, as you try to learn further, you could try to work on with different types of scenarios of connecting things, such as connecting your devices through Wi-Fi, Bluetooth, even as long range, a 2 kilometer range RF RF based systems. We call it as LoRa or long range systems. You know, so if you're fun with that, so you could try to watch this one on YouTube. It's a lot of exploration. Napakarami talagang pwedeng gawin gamit sa Arduino. Another project that I have, it's a little bit big. Hopefully, I could try to put this one here on my table. It's a tank. It's a robot tank that I have made. Well, the chassis is pre-made already. I tried to bought the tank. Then, if you'd notice, I connected a Raspberry Pi, and underneath that is an Arduino Mega. Yung may USB port. Medyo malaki, hindi ko na may pakita talaga sobra sa inyo. Siguro pakita ko na lang dun sa webcam. So this is how big the robot is. So this is a robot tank that I made. This one is actually, I made this one for my kid. But on the latter part, nung nagkaroon ng pandemic, I need tools and equipment and kits that could help our graduates, yung mga graduates na natin. Sila yung una naka-experience na to na they could try to control this one remotely. Na even at home, they could program the robot and try to maneuver the robot outside of my house. You know? So yun yung mga activities na ginagawa namin. And this is powered by Arduino and Raspberry Pi. The Raspberry Pi is the one that is connected to the internet, since the Arduino Mega has no capability of having it connected to the internet kasi wala siyang Wi-Fi built-in or wala siyang any internet connection built-in here. So I tried to use the Raspberry Pi connected to the Arduino, since the Raspberry Pi looks like a computer. It's a single board computer. So they could program on the Raspberry Pi and the Arduino, then play with it, then roam around the home. Roam around my home. You know? Naka-webcam siya so that they could see the maneuverability of the robot. And the camera is also connected online. So that is how we try to work on with with the projects. Another one, I'll show you this. We did this one way back 2015 or 16, if I'm not mistaken. We call it as the soccer bot. A group of students, students before have this project. We try to work on with a tennis ball, and they try to maneuver the robot wirelessly via Bluetooth. Ano? They put a Bluetooth module on the Arduino, put some motors with it, then try to play around. This happened summer of 2016, if I'm not mistaken, 2016, 2015, 2016. And this is done during night time. It's because so that there would be no disturbances in the class. So this is our activity, and at the same time a project of the electrical engineering students. So this was fun. This was a fun activity that we made. Now, moving on, so daming pwedeng gawin kay Arduino. There are lots and lots of things that you try to work on with the Arduino. Daming projects. No? If you would try to take a look on different types of YouTube channel like Angelo Casimiro, he tries to create his BB-8, yung Star Wars character as a robot na umiikot yung katawan, BB-8. He tries to create that. You could also create a quadcopter out of Arduino then. We'll be using a different type of board. You know? And again, yung pinaka-successful na product ni Arduino talaga na naging commercially available and naging popular at naging widely sabi nga natin, widely adopted is yung 3D printers. Isa yan sa naging produkto talaga ni Arduino. So, when we try to talk about Arduino inputs and outputs, kasi hindi natin pa magets kung ano ba yung sinasabi nating inputs and outputs ni Arduino. My analogy of this one is actually an analogy of a computer. What are the parts that is what we call an input in a computer? Keyboard, webcam, microphone. Those are inputs. Tinatanggap yan ni Arduino. Tinatanggap yan ni Arduino. Tinatanggap yan ni computer is because you are sending data. You're sending keys. You're sending your picture. You're scanning a file. The computer is receiving your voice. And that is what we call an input. And in an Arduino, the simplicity of the Arduino, wait for a while. Sorry for that. Moving on, so we have inputs. Sorry again. Sorry for the interruption. So, moving further, when we try to talk about inputs in the Arduino, these are the ones that receive signals. These are the ones that receive signals in your this one receives signal from a sensor or a push button, and it sends that data to the Arduino telling something. They supply signal. I would say that when we try to talk about inputs, we talk about senses. Sa katawan din natin, we call it as senses or sensors. Like our eyes, nose, mouth, and ears. That has a sense of sight, smell, touch, our skin nga pala, I forgot, hearing, and tastes. Sa Arduino, we have our push button, more on the touch. Photo sensor, it accepts light, so it's more like a sense of sight. Temperature sensor, again, more on touch or feel. Ano? What about hearing? You have also microphones or sound sensors in the Arduino that you could use, and that is an input. And we call it, sometimes we say it's, hey, there's something is happening out there. You need to check based on the program of what or how would you try to react. That is what inputs is telling us. Moving further, we have also understanding outputs. Pag sinabi natin output is what does the Arduino do or gives to the system, or how does the Arduino perform? How can an Arduino perform? So it means that the Arduino will send a signal to a particular device, and that is your output, and makes that output react. Ano? Kaya nga sabi din dito, these devices stay put until the Arduino says you need to turn on now, or you need to run the motor, or you need to display something, or you need to make a signal, a buzzing sound. That's why if you would see on the outputs, we have motors, LED lights. That's the most famous output of the Arduino as for beginners. Piezo element or piezo element for others. In the form of a speaker, yung matinis na tunog, lalo na yung sa mga Nokia phones before, yung mga 3310, 5110, if you have experience using that kind of phone, that was my first phone, 5110. The sound of that is actually a piezo element or piezo element. We have stepper motors and servo motors that gives a rotational accuracy, whether that would be angular or positional. LCD display or liquid crystal display, it displays text. Hindi naman siguro images. Depende kung ano ang ginagamit yung LCD screen. You could actually display even images. It depends on the type of LCD display that you are using. But nonetheless, yung mga basics such as what you see on the display here, sa natin, this is more on texts. We will be using this one later on if time persists. Now, next is what we call digital at saka analog. Ano bang pinagkaibahan ni digital? Or we call it as discrete. Sa tunay, ang tawag natin dyan is discrete, and the other one is the analog. Pag sinabi natin discrete, simple lang yan. On and off. Whether the device that you are using will be turning on or turning off, or 1 or 0, or true or false. One good example of this sa outputs is alin? Ilaw. Lamp. The next one is a push button. When you press, it turns on. When you release it, it turns off. It's a momentary push button. We call it as momentary push button. It sends a signal of either 1 or 0, true or false, or on or off. Sa Arduino, ang tawag natin dyan ay low and high. Analog naman is different from digital in the sense na it varies. Pag sinabi natin varying, just like with air conditioning, you could try to change the setting of your temperature from what? Let's say for example, from 16 degrees up until 30 degrees. That is analog. Temperature sensors detects temperature. So it means na hindi lamang siya 1 or 0, but it detects temperature levels. Let's say for example, the room temperature here is around 30 degrees, 25 degrees. Light sensor accepts light, luminance. So in terms of lux, sa mga nag-aaral ng illumination dyan, alam naman natin that the lux is what? A unit for intensity of light. Gaano kaliwanag o gaano kadilim. And analog is being used to control a wide range. Naka-range ka ngayon, hindi lang 1 or 0. Or hindi lang low or high. Pwede ding in between or meeting the high or meeting the low. So analog is being used for that. And sa ating Arduino inputs, you would see that on A0 to A5 sa Arduino Uno. Sa Arduino Mega marami. Ano? For the outputs naman, may specific pins tayo sa digital that you could use as analog outputs. Ano? So yun yung ating understanding between digital and analog. Ang nagustuhan ko sa Arduino is that you could put some add-ons on it. Pwede mo siyang ipatong sa Arduino to put additional features na kailangan mo sa inyong project. We call this one as what we call shields. Ang daming shields na available sa market na pag nilagay mo kay Arduino, you could do text blast. Ano? Naglalagay ka ng GSM shield. Lalagyan mo ng SIM card. You try to program it and you try to text blast your friends. Ano? Continuously. Tapos naka-unli. I try to say this one, I try to share this one sa mga students ko din, na you could do this one if you want to text blast a person every second. Magte-text na magte-text. Text blasting. Ano? By using Arduino and a GSM shield. And a SIM card na naka-unli for a day. Ite-text niya na ite-text every second. Pwede niyang gawin yun. Ano? Pero wag niyong gawin kung galit kayo sa kaibigan ninyo o sa kaaway ninyo. Huwag niyong gagawin ito dahil pwede na naman ma-block yan gamit yung Android phone ninyo. Ano? And at the same time, it's unethical. But you could do that. And some of the projects that have been made, mga thesis na ginawa, if they try to have an alert system using GSM, they try to use a GSM shield na nakakabit yung Arduino. So if something happens to a person, pwede nilang pindutin yung button dun sa Arduino, then it tries to send a signal and text sa nakalagay o nakasave na cellphone number doon sa program ni Arduino. You could put also Wi-Fi shields, so that you could connect your Arduino online. You could put GPS modules. Yung iba gumagamit ng GPS modules so that they could put it in their car so that they would know where the car is located at a certain period of time. Kunwari nanakaw yung sasakyan, may thesis na ganito, nanakaw yung sasakyan, umalis sa sasakyan, nag-activate ngayon yung alarm system mo, an Arduino-based alarm system, and ite-text ngayon yung tao using a GSM shield ulit, ite-text yung owner na nanakaw yung sasakyan at located sa ganitong area. So it gives an additional feature on the Arduino and makes it more flexible to work with. Napakaraming opportunity, sabi ko nga sa inyo. Sir, question, bakit hindi kayo gumamit dun sa dun sa project ninyo ng Wi-Fi shield? So it's a matter of what we call, number one, I don't use a shield on my project, in this project. It's because of economics. Mas mura kasi yung built-in na. Padalawa, yun nga, mas mura yon, way cheaper. Although limited lang yung input and output niya compared kay Uno, but I don't need as many inputs and outputs. It already has a Wi-Fi built-in, so yun na yung maganda doon, and way cheaper than putting a shield on an Arduino. 200 pesos sa Arduino, Then you put a Wi-Fi shield that costs around what? 500 to 1,000 pesos. And have the same features as this one. Then next is smaller footprint pag ginawa mo sa project mo. So this is how big my project is. Then kung maglalagay ako ng uno, or let's say for example a Mega, imagine niyo yung laki ni Mega, si Mega pa lang ito. Ito yung project, halos sakop na niya yung buong enclosure ko. And in my enclosure, I put there already a power supply, a sensor pa, and other peripherals such as relay to control the lights. So as small as this. So it depends kung gaano ba kalaki yung system na gagawin ninyo and how economical it is when you try to create your project. So you need to be resourceful enough, and you need to do lots and lots of research on how would you try to work on with this. But before, I tried to use wired Ethernet shield. So ibig sabihin nakakable pa. That is my first project before, na pag kinabit ko yung system ko sa router using a Ethernet shield and an Arduino and program it to control lights and fans. Ginawa na rin yan sa school on their thesis. I was their advisor, and we tried to control one room at DLSL using an Ethernet shield and an Arduino. So ang daming pwedeng gawin. So it's up to you on how would you try to be flexible enough, or how would you try to be resourceful enough when you try to work on with your project. Moving on, the software that we will be using, if you will be connecting your Arduino to your PC and try to program it, is what we call the Arduino IDE, or the Arduino programming software. So the Arduino Integrated Development Environment, or IDE, is a cross-platform. It means that if you're using a Mac computer, you have a software of Arduino IDE. You just need to download on their website at arduino.cc. Of course, Windows meron, and even doon sa gumagamit ng Linux. Sino ba dito naka-experience ng gumamit ng Linux? Like Ubuntu, that's the most famous Linux distribution that is available for free. Kasi ang Linux, most of the software for Linux are free. And one of its distributions, or one of its kind, is actually Ubuntu. Kasi naman nakagamit ng Ubuntu, para lang din siyang naka-Mac, kasi naka-Linux based yun. Even your phones, your Android phones, are actually Linux based. Pero another version of Linux, it's more on the mobile part. Pero sa PC part, ang ating Linux is more on, yun yan. Isa sa mga distros is Ubuntu. So you could download Arduino IDE, install it, and you could program your Arduino boards on this particular software. So before we go on with a little bit of hands-on, yung hands-on demonstration here, I'll just show you what are the things that we need in the Arduino environment. Again, Arduino is based on C and C++. So if you are now learning your computer programming 1 or 2, then you could actually program on an Arduino. Again, this is case sensitive, semicolon sensitive, braces, bracket, parenthesis, sensitive. So please take good note of your coding. So moving further, some of the portions of the Arduino that you must know are the icons that you would see, such as the verify, upload. When you try to talk about verify, is you try to check if there are any errors in your program, in your code. Upload is when you try to send the codes to your Arduino board Of course, you have your new, your open, and your save. This will be seen at the topmost portion or the top portion of your Arduino IDE. And on the lower portion, you would see there your text console and line number. Sa line number then, if you would notice, you would see there the type of board that the Arduino you are using and the COM port or the address of your Arduino. Later on, i-discuss natin yan. Some functions that you need to know, the basic functions that you need to know before we try to continue in our activity or before we try to work on with the demonstration. So you need to know about the void setup and the void loop. When we try to talk about the void setup as shown here, this is where you try to initialize your pins, initialize your communication with the computer. It means that when you try to talk about the void setup, it is being done once. It is being done once and you try to prepare the things that you need in order for it to run. In order for the Arduino to run properly. So that is within the void setup. On the void loop, on the other hand, this is actually the function on which the Arduino will run continuously. Habang buhay si Arduino, yan ang gagawin niya habang buhay. So it will run continuously in a loop. Walang tigil yan. So we know the void setup and the void loop functions. Here are some examples of coding when we try to talk about the void setup and the things that we need to know on the basics. Like the pin mode. When we try to talk about the pin mode, this is where we set the pins, whether the pin in the Arduino is an input or an output. And yung isa is yung serial begin. This is where we try to establish the communication between the PC and the Arduino. We will be talking more of this one later when we try to do the demo. I tried to show this one sa inyo so that you have an idea of what is in store for us when we try to program. Then, some basics din ng ating coding is yung sa loop function natin, we have digital write, the pin number, and the pin status. This sets the pin either high or low kasi digital. Digital write, you are sending a signal to an LED whether that would be on or off. Digital read is when we try to get the data coming from a sensor, whether that would be digital. Let's say for example a push button. A push button is also a sensor that when you try to press, it will try to read 1 to your Arduino. Pag nakabitaw ka, 0. Then serial print line, this one is for monitoring of the conditions in serial. Okay. Moving further, we just have some small pre-activity or some refresher muna on the circuit, concepts about circuits. Number 1, simple circuits. We all know about series and parallel. This is more on the idea of the connection of things. When we try to talk about series, this is in the form of a loop where if one component is removed, everything now becomes an open circuit. Pag parallel, on the other hand, we try to put these things across. Kaya nga tinawag natin in parallel. Across the supply, and even if one component is removed, the whole circuit is not totally affected, unlike with series circuit. Circuit diagram, it is important for us to have a circuit diagram so that you could try to design your circuit first before deploying it into actual. So please take note of that. Sa mga electronics and electrical engineering students and even CS and IT students, kasi nasa part tayo ng site. Ohm's law is very important to us. V is equal to IR, or voltage is equal to the current flowing through the resistor. Is the voltage is equal to the current flowing to the resistor times the resistance of a particular material. So yun yun. Breadboard. Breadboard is very important for us in our simulations, whether that would be virtual or actual. It's because you try to put your prototype connection through what we call a breadboard. So this is a good example of a breadboard where, tatandaan ninyo, when you try to look at the sides of your, if you try to take a look at the sides of your breadboard, these are all connected. Itong horizontal na to, itong horizontal sides na to, these are all connected. Also, these are all connected, itong sides na to. Pag ganun. Pero hindi siya pa vertical na magka-connect. It means that this one and this one are isolated. Pero yung pahabang yun, yung pahalang na yun, connected yun. Pag dito naman sa gitna, dun sa middle portion, ang magkakakonekta is ito. Magkakadikit. Pero ito at saka ito, hindi siya magkadikit. So, sa vertical sides naman siya, sa vertical position naman niya siya, magkaka-connected o magkakadikit. Magkabit ka dito at magkabit ka dito, iisa ang linya ng kuryente niya. Kung maglalagay kayo. So, the breadboard is mostly used. The breadboard is mostly used for simple applications or simple activities such as creating a basic circuit before putting it to a what we call printed circuit board or PCB. Hopefully, we have some activities or demonstration later, demonstration of a seminar which pertains to creating PCB or printed circuit board. If not, I would suggest one YouTube channel. It is made by Angelo Casimiro. Try to search that on YouTube, Angelo Casimiro. He created a YouTube video on how to create a printed circuit board. I think it comes from designing down to the creation of PCB. Meron siyang discussion tungkol doon. But, again, in this situation, sabi ko nga sa inyo, we cannot try to actually work on with a breadboard, with an actual Arduino. So sir, how do we try to work with this one? Kasi bibili pa kami, ang problema pa, ang hirap pang bumili. Matagal din dumating. If it will be coming from China. And, syempre sir, medyo we try to also look at the situation, lalo na sa family namin, na baka hindi kami makabili agad-agad. Well, no worries if you want to create basic applications or basic projects on the Arduino, even without any hardware. That's where Tinkercad and Tinkercad Circuit is there. Tinkercad is free. It's an online 3D modeling program and at the same time a circuit simulator that you could use to create projects, small projects, and try to work with it. Ang gusto ko dito sa Tinkercad circuits is that when you try to create your circuit, you could try to create your own 3D enclosure at the same application, online application. No need for AutoCAD. Kung magpo-prototype kayo, no need na for AutoCAD. Why? It's because Tinkercad has its own 3D software. And it is also a product of Autodesk. So, ibig sabihin, naka-govern siya kay Autodesk. So, ibig sabihin nun, you could import your 3D model na ginawa nyo kay Tinkercad and look at it on your AutoCAD software. Then, as students, AutoCAD software is also free. Kaya, sabi ko nga sa inyo, ang daming resources na industry-based that are free for us and we could try to utilize it for engineering and design purposes. Ano? Nakakatuwa, ano? Even EagleCAD, the PCB software na pwede nyo din gamitin is also free from Autodesk. Kaya that's why I'm encouraging you last time, even before ng starting ng class, na mag-text blast or mag-FB post ng videos about getting AutoCAD for free. Sir, 1 year lang namin makukuha yung free na AutoCAD. No worries, because you could renew that as soon as it expires. Ano? And you could get a new version of AutoCAD for free pag ganun din. Sir, student version, okay lang. The student version is actually a complete non-commercial application ng AutoCAD. So it means everything you see right now, pagdating sa design and engineering from Autodesk are free for use as long as you are a student or even a faculty. I myself is using now AutoCAD 2021 and I'm also using Tinkercad in my basic simulation process and demonstration of Arduino. So wala kayong magiging problema sa paggagawa. Now, I'll be sending you this PowerPoint presentation. I'll be sending this to the ISEP community and JIIEE and even on GPCS and ACES since I'm linked with their group page. And I'll be sending you lots and lots of activities here. We will be tapping some of the activities that you see right here, ano? And try to explore using Tinkercad kung wala pa kayong mga gamit. Kung may mga gamit na kayo, you have an Arduino kit at home, then you may try this one at home. So let us try to have some demo. I will not be using this one, but rather I'll be first creating this one on Tinkercad. How to code with this and how do we try to work on with the coding with the Arduino for both Tinkercad and yung actual na. Paano pag nag-actual na kayo? So first things first, I'm now at the Tinkercad circuits. This is Tinkercad circuits website. Then from the Tinkercad circuits, I need this following components. First, I need to get an Arduino Uno. Please make sure that your components are put into all so that you will see all the components, all the basic components that the Tinkercad has. Actually, all the components that the Tinkercad has. So I need an Arduino Uno. So I just zoom out. Then I need a breadboard. Hanapin natin si breadboard. Gagamitin ko lang is a small breadboard. Oops. Lalagay ko siya dito sa ano. Next, I need an LED. I'll be using a red one. You may change the color of the LED by clicking on the LED, then clicking on the color that you want. So to be noticeable, I'll be putting this one on red. Then I need a resistor. So that the resistor that I'll be using is 220 ohms. So you may change the resistor value, and as you see, ang kagandahan din ni Tinkercad, when you try to change the resistance value, the color coding of the resistor also change, making it visible for those who knows how to read resistor color coding. I will not be discussing about that. This is further discussed, I think, on your electronics workshop and electrical workshop. Sa mga hindi naman fond or enthusiast, since hindi naman natin masyadong gumagamit na lang tayo ng tester, and we test the two leads of the resistor to check for the resistance. So, what do we do after this? So the project that I'll be making is a blinking of an LED lamp. Using the Arduino Uno. So ang gagawin natin is I try to move this LED and put it on the breadboard. Again, nasabi ko sa inyo, the vertical lines here, yung vertical lines ang magkakakonect, pero the horizontal lines or the horizontal here, are not connected with each other. So pwede siya. So safe tayo dun sa ginawa natin ito. Hindi magso-short yung ating LED. Sunod. I will get the resistor. Ito. And I need this one to be rotate. Kailangan ko siyang i-rotate. So you have your rotate icon here. Ito. Nasa upper left portion ng ating Tinkercad application. Then I try to rotate so that it becomes a horizontal orientation. Then i-move ko siya. Move ko. And I will be connecting this one sa tabi ng ating LED. Notice, I try to connect the resistor, yung isang end ng resistor, dito sa end ni LED. Then may mapapansin kayo, sir, bakit yung isang linya ni LED ay baluktot? Yung isang linya ng LED o yung isang terminal ni LED, yung wire ni LED baluktot. Yung baluktot kasi yun is a representation. I have an actual LED here. If you would notice na yung dalawang leads ng ating LED ay magkaiba ang haba. Ito at saka ito. Mas mahaba ito kaysa sa dito. What does it mean? What does it denote? Sa LED kasi meron tayong tinatawag na anode and cathode. Positive and negative leads ng LED. Para malaman mo kung alin ang positive, alin ang negative, yung mahabang terminal ni LED, yun ang positive, at yung shorter na line, yun ang negative. Yun yung kakabit mo sa negative. Pag pinagbaliktad mo siya, hindi gagana yung LED. Why? Base sa electronics, ano nga sabi natin doon? Pagbaliktad yung terminals ng diode, sa mga electronics and electrical engineering students dito, this becomes what? Reversed biased. So please be careful with that. So, yung terminal na to nakakabit doon, and itong terminal na to is connected here. Now, so ito magkadikit, tapos ito, solely lang ito. Ang sunod kong gagawin is I'll be connecting itong sa anode kong ito, ikakabit ko siya, since magkakadugtong naman to, ikakabit ko siya sa pin 13. Sir, paano nagkaroon ng wire? I-click mo lang yung isang terminal na kailangan mo sa breadboard mo. Then, pagka-click mo, i-click mo naman siya sa susunod na destination na pupuntahan, which is yung ating pin 13. Kung gusto niyo na medyo nakaayos, gusto niyo naka-straight, i-double click niyo lang yung wire niyo so that it would create another node. Then, pwede niyo siyang i-stretch. So, gusto niyo nakadiretso? So, ganito. Double click nyo ulit para magkaroon uli ng node. Then you have this arrangement. By the way, you could try to change the color of your wire. Pag ito ay nakakabit sa mga pins, kadalasan ng aking iniisip, this would be color red, indicating that I'll be sending a positive signal to my LED. Tapos yung dulo ng resistor ko dito, itong dulo, I'll be connecting this one to the ground. Ito, G and D. So bago ko siya ikabit, I always like to do this one. So ito, click, tapos i-click ko dun sa ground. I'll change the wire to black. Kasi pag ground or negative, that signifies a black color. So, arrange lang natin para malinis tingnan. So, I have now my LED connected to the Arduino. Next, how do we try to code on Tinkercad? How do we try to code on Tinkercad? So yung makikita nyo dito, on your right side naman of the screen, you have your code, start simulation, export, and share. I'll be using the code part to create my code. Excuse. You would notice na meron kayong way ng pagko-code, and this is a coding on what we call blocks or blockly. Ito ay kadalasang ginagamit kung ang aking tinuturuan ay mga elementary and high school students. To get to know basics about programming in the Arduino, the easy way. Well, easy din naman ng C++, don't worry. Ang gusto ko kasi pagdating kasi sa higher levels is that you know how to do programming, most especially when you try to do coding, conditional statements and looping statements, which is also done in blocks. But it is better for you to understand it on coding. So, ang ilalagay ko dito, instead of blocks, I'll be putting this one as text. So, nakasulat dito, are you sure you want to close the blocks editor? Yes. And I have this. Matik, nabigyan na tayo ng code dito. Ano? But I'll be trying to remove it for the sake na para maintindihan natin yung ano, yung code. So I have again void setup and void loop. So ma-maximize lang natin para makita muna natin yung code. So I'm now at my code. Ano yung lalagay natin kay void setup? Again, si void setup ang nag-i-initialize ng ating Arduino on the first time of use. So, sa pag-setup natin, kailangan natin ma-initialize yung mga parameters na kailangan natin for the Arduino. So, ang una dyan na makikita ninyo, gagawin ninyo sa pag-initialize ng setup is, una, saan bang pin ako gumamit? So, I'm using pin 13. The pin 13 right now acts as an output. Sir, bakit yung sinabing output? Remember, nakadikit yung pin 13 natin saan? Sa isang LED lamp or LED light, which is what? An output. Ano? Output sa LED. So, ibig sabihin, kailangan ko ma-establish na si pin 13 ay isang output. To do that, I'll be using pin mode. Open parenthesis. Ano ang pin? Pin 13. Comma, then output. Don't forget to put the semicolon. Then void loop. Doon na tayo sa void loop. Ang void loop naman ay yung function na kung saan paulit-ulit niyang gagawin yung program. Since ang gusto kong gawin is ipa-blink yung ilaw, so ang una kong gagawin is digital right. Bakit right? Kasi magsasend ako ng signal na on o 1 papunta kay LED. So ang mangyayari, digital right, anong pin yung gagamitin natin ng pang-on? 13, anong unang status niya? High. Ibig sabihin niyan, bubuhayin mo yung LED ng pin 13 o bubuhayin mo yung LED na nakakabit sa pin 13 at paiilawin mo. Next, we have a command called delay. The delay is a command that sends a certain pause kay Arduino in terms of milliseconds. Yung ilalagay mo sa loob is in terms of milliseconds. So kung 1 second yung gusto kong delay, the delay here must be in terms of 1,000 milliseconds. Then, ang gagawin ko dito, alam nyo, paste, copy, paste. Control C, Control V. But instead of high, yung gagamitin ko kay pin 13, gagawin ko siyang low. So sa unang launch ni void loop, iilaw yung aking LED. After 1 second na delay, i-off ko sa LED. Then after 1 second, babalik uli siya kasi sabi ko nga sa inyo, void loop, pagka delay ng 1 second, babalik uli siya sa high. Then 1 second low, 1 second balik uli yung loop natin, which is going to high again. So tapos na yung program natin. This is our first Hello World tutorial kay Arduino. I call this one as Hello World ni Arduino. So paano tayo mag-i-start ng simulation? So just click on Start Simulation. Sa ano napansin ninyo? Your LED now blinks. Okay po ba? Naiintindihan? Pakichat ako kung okay naiintindihan po at nag-gets po yung ating nagawang project. Okay po ba? Ayos po ba? Malinaw po? So don't worry, this is all recorded. These are all recorded and you may try to review back again if you want to. Now, nakagawa nyo na to sa simulation. Ito maganda sa engineering ngayon, lalo na't meron tayong mga computer applications that do the simulation for us. Once that we're done with the simulation, now is the time naman for us to do the actual simulation. Kasi ito, software lang, pwede ba natin itong igawa ng actual? So, ang gagamitin ko is an Arduino Mega kasi ito yung available ko na easily accessible sa mga ports. Medyo ito nga, yung Arduino Uno ko nakapatong-patong sila, no? The top side nga pala, by the way, is a temperature sensor. We call it as the DHT11. Ito. So, I'll be using an Arduino Mega, a breadboard, a blue LED light, some wires, and a 220 ohm resistor. So I'll be switching to my frame again. So ito yung ating breadboard. Lalagay ko lang. This is my Mega. Then, before I forgot, you need also a USB printer cable. Ano? Your USB printer cable. Pag bumili naman kayo ng Arduino sa Lazada or sa Shopee, you will also receive this USB to printer cable. Medyo maikli lang siya. Ano? About a foot long. Ano? But I think this is enough for you for small projects naman. In case na walang ganito, at may printer kayo sa bahay na ganito ang kabitan niya, it is actually a USB type B or a USB printer cable. You may first borrow it sa inyong printer at gamitin ninyo sa Arduino. Walang problema po doon. Now, back again with the Arduino Mega. Please make sure that before you are connecting any device on your Arduino Mega is disconnected from your PC. Ano? Do not connect it yet to your PC. Kasi nakabuhay agad ito. Ano? For safety purposes. Sir, makukuryente ba kami pag ano? Well, maliit lang. Kasi ang kayang i-deliver ng Arduino ay maximum of 40 milliamps. Kung makuryente man kayo, para kayong nakiliti, pero ingat din. The smaller the current, sometimes the deadlier. Again, as low as 100 milliamps could kill you due to cardiac arrest. Ganon kababang kuryente lang ang kailangan para kayo ay ano? So please take note of that. So wag niyong mamaliitin din ang kuryente. So I'll just be getting some so I'll be mimicking what we have designed here sa ating dito sa ating Arduino Uno. Same din. So I'll be connecting my pin 13 0, 1, 2, 3 7, 8, 9, 10, 11, 12, 13. 8, 9, 10, 11, 12, 13. So I need my pin 13. I'll be connecting it here. Anywhere sa ano. Basta as long as you try to follow the rule of the breadboard na pag vertical, ito yung magkakakonekta, pero pag nag-horizontal, hindi na. So medyo mahaba yung ating wire na ano. So I connect my, oops, sorry. I'll be putting this one to ground. Then I have my LED. So kailangan magkatapat ito. Yung terminal na to at saka yung negative side na to. So ito yung nakakonekta ngayon sa ground. I changed from pin 30 to ground. Kasi ito ang gagawin kong ground. Ito yung resistor ko nakakonekta sa negative ng aking LED. Then the LED, yung isang terminal ng LED, I'll use an orange wire. Yun ang available sa akin. Then connect this to pin 13. So that is our connection. Once that you are finished with the connection, then that's the time for you to connect your USB cable and connect it to your PC or laptop. Okay. So I've connected now my PC, my Arduino to my laptop. So ito yung ating LED. Connected na siya. Now, the next thing that we need to do is to open your Arduino application. So, preference. Palalakihin lang natin yung ating text. Kita naman ano, kita yung text ng aking Arduino, ano? Okay naman po?
Yes po, sir.
Okay. Ito na lang ang technique. Same program na ginawa mo. Of course, kasi itong program na to is also applicable on your Arduino Uno. So, I'll stop my simulation. Copy the code. And what? Paste it here. Once that you paste your code, verify it first. Check lang natin kung may error. Pag nag-click kayo ng verify, you would notice na pinasa-save mo na yung sketch nyo. Then you may save your sketch. Sige, ang gagawin ko, I'll be saving my sketch. Then the saving of the sketch on default is the, if you would notice, it says here that sketch underscore the date today, then A. It means that is your first program during that time. So, pwede nyo gamitin itong klaseng format. Again, by the way, when we try to talk about sketch, that is the program of the Arduino. Ano, yan yung tawag sa program ni Arduino. We call it as sketch. Para hindi masakit sa tenga na, uy, gagawa tayo ng program sa Arduino. Parang pakinggan eh, parang requirements eh. Pag sinabi mo kasing sketch, oh tara, gawa tayong sketch sa Arduino. It's like you are trying to draw something. Yun kasi yung concept kasi ni Massimo Bansi. That's why he didn't talk about programming, but rather you are trying to create an art or a design. Again, I always tell this, engineering is all about the concepts of discipline and art as well. So bakit yung sinabing art ang engineering? Kasi it depends on different types of engineer on how would you try to create a good design based pa rin sa code, based sa theories and concepts natin, and even the Bible for both electronics, electrical, computer, or industrial engineering ang pinag-uusapan natin. Based on the discipline that we have, and the artistry behind that is, ang art dun is yung diskarte mo. How would you try to perform it? How would you try to make it economical? And that's the art of doing it in the engineering way. Ano? It's still an art. Ano? Nakakatuwa. Ano? Kaya nga sabi ko nga, if you are an artist person and you are also into engineering, napakalaking bagay kasi na meron kang tinatawag na art din kahit papano. Ano? Kahit ikaw ay isang engineer. So, copy-paste lang ako. Pagka-verify ko, the next thing that I need to do, the next thing that I need to do right now, kasi medyo natabunan kasi yung file natin, is to go to tools, then unahin ko muna yung board. So ano bang ginagamit kong board? Yun yung ibig sabihin dyan. Since I'm using an Arduino Mega, at dinownload ninyo yung latest version ni Arduino na software, hahanapin mo yan sa Arduino AVR boards. Then you will be looking for the right board for you. So since ang sa akin ang ginamit ko is Mega, so ang gagamitin kong board is Arduino Mega or Mega 2560. Kung Arduino Uno naman ang ginamit ninyo, dahil yun yung nabili ninyong kit, so you will be using an Arduino Uno. So naka-default na tayo, Arduino Mega yung ginagamit ko. So I'll be choosing Arduino Mega. So yun yung una mo muna gagawin. So go to Tools, then Board. After mo magawa yung Tools then Board, you need to select your port. Ang kagandahan ngayon sa mga latest version ni Arduino, and if you are not using a very weird na Arduino compatible microcontroller or yung clone na sobrang Chinese brand, sorry for not for the discrimination, kasi ang mga Chinese talaga yung gumawa ng mga boards na may kakaibang drivers na ginamit. If you would want to know what are the drivers na sinasabi ko, it's either that they would be using a prolific drivers or yung tinatawag namin din isa pa, yung CH340 na drivers. So those are the two drivers na kadalasan ginagamit ng mga Chinese, highly Chinese brands na Arduino clone. Pero kung ginagamit ninyo is yung mga medyo may konting kamahalan lang, kasi paminsan pag yung sinasabi ko kasi yung mga Chinese clones talaga na medyo kailangan mo pa ng drivers, that is ranging from 160 plus pesos sa uno. Yun yung tinatawag kong SMD version or surface mounted device na Arduino. Pag sinabi natin surface mounted device class, is yung board mo is naka-soldered sa Arduino. Hindi mo siya pwedeng tanggalin yung chip sa Arduino Uno. At meron na to. Itong chip na to. Kasi ito yung driver ni Arduino. Yung driver ng Chinese part na Arduino. But if you're using yung medyo expensive, from 160, ang binili mo is yung medyo 250 na Arduino clone, hindi mo na kailangan ng drivers doon. And, pag pumunta ka sa port, ang kagandahan doon, pag pumunta ka sa port, nag-auto-detect kung anong klaseng Arduino ang gamit mo. So, it is on COM4, then nakikita niya kung Arduino Mega o Arduino Uno or Arduino yun ang gamit mo. So, yun yung kagandahan ng paggamit ng medyo may kamahalan na Chinese brand na Arduino clone. And still, it's cheap. 250 pesos, Arduino Uno. Kumpara nung panahon namin, na ang Arduino Uno, nung way back 2010, is around how much? 750 pesos. And it tends to kill your laptops for some time. Kasi galing kay Igis mo, may konting bugs pa yon na pag kinabit mo kay laptop, pag Windows 7 yung laptop mo, pag kinabit mong ganun si Arduino, magbo-blue screen yung laptop mo. Ang daming cases na nangyari noon sa mga ECE and EE students na nakakakonsulta natin sa sa kanilang mga projects. So please, pero ngayon hindi na naman nakaka-blue screen itong Arduino. Don't worry, it's safe na ngayon. Kasi it's fully clone version talaga ni Arduino. So after all of this, after you have verified it, nailagay mo na yung ports at saka yung board mo, then it's time for you now to upload your program. Please check doon sa inyong terminal if it is done uploading. Once that it is done uploading, then now is the time for us to check yung ating actual na ginawa. As you can see, my LED light is blinking. And at the same time, kung mapapansin niyo, sir, may sumasabay ding ilaw. Ito. Bakit yan sumasabay yung ilaw niyan? Sumasabay ang ilaw niyan is because this one is connected to pin 13. Ito yung sa part ni Arduino nung diniscuss natin kanina na ito yung tinatawag natin pin 13 LED light. Kaya nga kadalasan for starters talaga, kagaya ko noon, nasabi ko, bibili lang ako ng Arduino. Bakit? Anong gusto ko lang matest? Magkaroon lang ako ng confident na magawa ko yung program ko by using the blink program and try to check on the pin 13 na LED kung iilaw. Kahit wala pa akong LED, ito ang pan-check ko kung nagana yung program ko o hindi. Ano? This is how I try to check my work. Ano? And up until now, basta pag nagte-testing ako ng Arduino, of course, I'll try to check if this one is lit, na ilaw ito, kasi ito yung power LED ko, but also at the same time, ito din. Sine-check ko kung nailaw din. O nagbi-blink base sa program, sa blinking program. Kung ito ay nakailaw nga, yung power LED nakailaw, pero nung in-upload ko yung program ko ng blink, eh hindi ito nagbi-blink, there's a possibility na may problema yung board ko o board ninyo. So this is how we try to do, sabi ko nga, this is how we try to do an engineering way sa panahon ngayon ng pandemic. If we don't have any hardware, we resorted to simulation. But if you have both, the best of both worlds, you have your software, you have your hardware, then you may try to recreate your scenario by designing your online simulator and put this one into actual. Ito yung ginawa natin ngayon. This is a good practice for us for engineering students, not only for engineering students but for all engineering and electronics hobbyists. Even computer science is engaged on this. Mabigay ka lang ng design sa engineer. Ito yun, bilang ComSci, I need to create a program in such a way that I create an Internet of Things device. Alam ko na yung concept ko, alam ko na yung gagamitin kong program, Android application ko, Android development, iOS development, database na gagamitin ko. Then once na na-propose ko yun, then that's the time for me to consult an engineer to do this. Sila na ang gagawa nito para sa inyo, then ikaw na ang gagawa ng program para dito, and the outside program that would control your microcontroller. It's a good collaboration between two different departments, from the ComSci and IT department and to the engineering department. They do some collaboration to create good designs. Hopefully, meron tayong magawang ganun on the student level. Sa faculty level, meron na. Ano? I, Sir Mark De Vera, Sir Cabrera, and Sir Rojas are doing collab. Ano? Si Sir Mark, alam naman natin na he is a ComSci undergrad with a Masters of IT. Ano? Siya yung sa software development. Kami naman ni na Sir Bugit, na Sir Jojo, we are on the hardware development, and we try to combine this to create a good project such as this. And this is still on the phase 1 kasi ang phase 1 is the hardware project. The more on the hard-coded software development and implementation is coming na from Sir Mark. And I as well, kasi nade-develop din ako ng software. Napakagandang collaboration nun. Ano? Tips sa mga engineering students, most especially who will be taking their thesis. Hindi po masamang magpa-program. Hindi po masamang magpa-program. May malaking konsepto kasi na, Sir, kailangan kami din po talaga daw ang magpo-program, kami yung magaganito. No, that's not like that. Ito ang advice ko sa inyo, sa mga engineering students who will be taking their thesis and they have software development. Ano? Number 1, you need to learn how to code, of course. Kung ang gagawin ninyong prototype and you are working with such kinds of things like this one, Arduino, walang problema doon. Number 2, you are the one who will be designing the whole concept. From the methodology na gagamitin ninyo, mag-neural networks kami, gagamitin namin is scheduling, gagamitin namin is linear, polynomial regression, support vector machine, k-nearest neighbors, kasi ito yung nasa study namin, Ito yung applicable sa study namin. Then, combine this one and try to create your own design. Design tayo, design ng engineering. Then, pwede natin ipasa sa iba yung konsepto natin. But not the programmer is the one that will be dictating you. Dapat ikaw dapat na magdidikta based sa design mo kung anong gagawin mo. Kung anong gagawin ni programmer. It's not the programmer that will be dictating what will be the case for you. Yun ang sinasabi kong pagpapagawa. Sablay yun. Kasi hindi mo na-design yun. Design na ni programmer yun. Which is a wrong concept. Dapat nanggaling sa inyo ang konsepto. Then from your concept, from your design, from your flowchart, from your analysis, ipapasa niyo yan sa mga programmers. Then the programmers will be the one being dictated. Kasi design nyo. And at the end of the day, hindi nila masasabi na kanilang design yun. Sila lang yung nag-code. But the concept, the design, the brains, is sa inyo. Don't forget about that. Walang masama kung hihirap kayo mag-code o magpapakode kayo sa iba. As long as yung konsepto mo, yung theory mo, yung design mo ay sa inyo. Just like what I did in our project. Hindi ko lahat ginawa. Hindi namin lahat ginawa. Ano? Hindi ko lahat ginawa from the coding of from the hardware down to the software. Sa akin yung hardware. Pero ang konsepto ng hardware, diniscuss ko kay Sir Mark. Sir Mark, ito po yung ating concept. Paano ko ba i-deliver yung data sa inyo papunta sa software ninyo? Ganito, kung kaya mong gawin ng ganito, sige, i-design ko ng ganon. Then ipapasok ko kay Sir Mark, then Sir Mark will be developing the software. Did I make the whole project? No. Because may collab ako na ComSci. But is it our idea? Yes. It is our design? Yes. So please take note of that. So when you try to work on your thesis, kailangan yung konsepto sa inyo, yung design sa inyo. So on our last part of this discussion, I'll be little bit advancing. Gusto ko kasi magkaroon kayo ng idea on how fun an Arduino programming is. And I leave the PowerPoint presentation. It's a very detailed PowerPoint discussion na pwede ninyong gamitin if you want to play with Tinkercad. And I leave it up to you, yung PowerPoint presentation. Kasi ang daming activities nun, 7 activities. This whole workshop is actually, when I try to discuss this one, is being done on a 3-day basis. But during a short period such as this, I'll be giving you one basic, which is this. Then, if you would allow me to extend a little bit, around 30 minutes, I'll be having at least 2 small projects that you could create. And you could see this one on the PowerPoint presentation. Pakita ko lang sa inyo using Tinkercad. Kasi ito lang, nandito kasi yung mga available nating components. Oh, how fun it is to actually do the coding. And I'll give you some, I'm giving you some guides. Lalo na pag gumagamit na tayo ng tinatawag nating libraries. Libraries. So I'll be removing my LED. Resistor. I'll create na lang a new circuit. So on my Tinkercad circuit, so you have create a new circuit. We start from scratch. So I need okay lang ba na mag-extend tayo kahit 30 minutes lang? Okay lang po ba? 2 projects lang. Yung isa pre-made na, pakita ko lang sa inyo yung fun ng paggamit ng LCD. Meron naman din yan sa PowerPoint presentation. I just want to give you how would you try to work on with some of the projects. Okay lang po ba? Okay, good. So I'll be using this. Pwede kayo gumawa ng mga small projects at home, ano, or big projects na may application talaga sa tunay ng buhay. Alam naman natin na kunwari, pag naghahanap tayo ng signal using a satellite dish, ano, you need a motor to actually tilt the satellite dish to doon sa signal o ipivot natin yung satellite dish based doon sa signal na gusto natin. Hindi ako nakawaya. Ito yung satellite dish. Gusto natin i-position siya sa gusto nating lokasyon. Rotational. Ang gamit natin doon is what we call a servo motor. A servo motor kasi has a precision to do 0 to 180 degrees of freedom of rotation. So gagamit tayo ng servo motor on this particular activity. You would see this one on our PowerPoint presentation. I think this would be on activity number 4. Ang ganda ng mga activities dito. You may try to play with the activities here. Have fun. If you have some questions, just stop me on my Facebook page. Or, if I upload this one, kasi I'm record this one right now, I have a YouTube channel. Alam yun ng mga third year ano natin. And alam din ng SG government yung aking YouTube channel. You may try to tap on my YouTube channel. Subscribe po. Then, I'll upload this one. If you have some questions, you may comment on the YouTube link. So I'll be creating this one. So I have my Arduino Uno. I need a potentiometer. A potentiometer is a variable resistor na pinipihit ninyo. One good example of potentiometer is you can see on a volume rocker sa inyong mga components sa bahay, sa mga stereos ninyo. Yan ang gamit natin is potentiometer. Meron nga lang iba, pag digital na, hindi na siya potentiometer but rather we call it as a rotary encoder. It's way different. Pero yung ginagamit natin is yung mostly sa mga lumang aparatus or lumang radyo is potentiometer. Please wait for a while. Okay. Going back. So I need a potentiometer para ito yung pipihit ko, para yung motor ko would change its direction of the servo motor. Then hahanap tayo ng servo motor. Ang servo motor na gagamitin ko is a micro servo. Para pag in-apply nyo to in actual, pag in-apply nyo po to ng actual, kakayanin ni Arduino yung power para ma-move si servo motor. Kasi yung may isang malaki dito na servo motor, if I'm not mistaken. That servo motor is only used if you have an external power supply. So ang ginagamit ko is yung micro servo. Maliit lang siya, and it's a fun servo to use. So ito yung servo motor natin. I try to rotate this one horizontally para madali ko siyang ikabit sa Arduino. The connection for this one is quite easy. Ang servo motor has 3 pins. Sabi daw dito, meron siyang signal pin, signal port, power port, at saka ground port. Yung signal port, ito yung ilalagay natin sa digital pin ni Arduino. So this time, I'll be putting the signal pin kanino? Kay pin 2. Doon ko muna siya ilalagay. Doon ko siya pala ilalagay. So again, you have your pin, then papalitan ko to ng kulay, gagawin ko tong orange. Yung isa naman is power pin. Ibig sabihin, yan yung supply ni servo motor mo. And you need to connect that power to what? To your 5 volts. Ano, meron tayong 5 volt trailing kay Arduino. Ito siya, 5 volts. So, ikakabit ko si 5 volts sa power ni servo motor. I change the color of this one to red. Double click para maayos ko yung wires. Then finally, ground. Ikakabit ko siya sa ground. Maraming ground sa Arduino, pero iisa lang din yan. Sa tingin ko, dito ko na lang siya ilalagay. Any ground will do ha. Iisang connection ng ground natin. I'll change this one to black. Double click para maayos yung ating wire. So that is how we try to connect the servo motor. The next one is potentiometer. A potentiometer has 3 terminals. Yung unang terminal mo, yung leftmost portion ng ating servo motor will be connected to our 5 volts din. Double click. Double click. Then, papalitan ko to, gagawin ko tong red. Yung huling dulo din, yung huling dulo naman, hindi sa 5 volts ha, sa ground naman. So, dulo-dulo is 5 volts and ground. Typical yan sa mga resistor-based systems. Ano? Yung mga may 3 terminals. Then, gagawin ko siyang black. Then, yung gitna, since ang potentiometer is varying, nagbabago siya, meaning, dapat yung potentiometer mo ay nakakabit sa analog pin. So, ang analog pin natin is, ito, from A0 to A5 ng ating Arduino. So, ito yung analog input natin. So, bakit input? Kasi magsisend tayo ng signal. Whether that would be 0 to 5 volts. Gagawin ko siya orange. Okay. Our system is all set. Our hardware is all set. Lapit-lapit nga kaya natin ito. Yan. Para okay siya. So, ang ating ginamit sa servo, which is our output, is pin 2. Then, yung analog natin, yung potentiometer natin is connected to the analog. Gawa tayo ng code. Text tayo. So, papalitan natin yung void setup natin. Void setup, delete, and void loop, delete. Una-una sa lahat, when you're trying to work on with servo motors, meron siyang specific na tinatawag nating libraries. Kasi namin nating libraries, Arduino, it's just the same with what we learn in computer programming and C++, na kung saan dinadagdagan natin ng additional feature yung programming natin to access the things that we need. Ano ba yung mga kadalasang ginagamit natin sa library sa C++? Math.h. Kung meron pa bang Math.h? Matagal na kasi ako hindi nakakapagsina. Conventional input I/O, yung ang tawag ko is conio.h. conio.h. Nagkakaroon tayo kasi ng conventional input outputs kung gusto niyo gamitin sa C++. Sa Arduino ganun din. Since gagamit tayo ng servo, we need to add libraries. Ito yan. Itong icon na to. Add libraries, and we need to use what? Ito, servo. Mapapansin niyo sa taas, Kagaya din ng C++ o C, nagkaroon siya ng include servo.h. Next, de-declare tayo ng tinatawag nating global variables. Pag sinabi nating global variables, ito yung nasa labas ng mga function natin ng void setup at void loop na pwedeng gamitin ni void setup at saka ni void loop nang walang problema. Kasi global. Ibig sabihin, pag ginamit mo kay void setup at may ginalaw ka dun sa value na yon, pati kay void loop mababago din. So, yun yung ating gagamitin. Global. Marami tayong globals na gagamitin na variable. Tandaan ninyo, meron tayong mga global variables, marami tayong kailangan i-declare. At marami tayo ding variable declaration. Integer, float, long, character, meron din string, yun yung variable declaration natin. So sa atin is, gagamit tayo ng integer. Int, yan yung variable declaration natin. Then what variable are we using? Pot pin. Ano ibig sabihin ng pot pin? Pin ng ating potentiometer. Ang pin ng potentiometer natin is located at A0. Pwede ko din siyang i-declare lang na 0. Then, int servo pin. So, saan ba nakakabit yung ating servo na signal? Sa pin number 2. Don't forget the semicolon. Sunod is, i-declare natin din yung object ng servo. Sinabi natin object ng servo, yung parang pinaka-variable ni servo. So, ang gagawin ko is servo, then ang variable ko is motor servo. So, yan ang ating variable declaration. Global variable declaration. May idadagdag pa pala akong isa. Int value. Gagawin ko muna siyang initial na equal sa 0. So, potentiometer pin, servo pin, int value, yun yung value na mamaya natatanggapin later on galing kay potentiometer. Then, servo motor. Now, sa void setup natin, kailangan tayong mag-declare ng mga pins. Sir, gagamit po ba tayo ng pin mode dito? Kay servo motor, hindi. Ang gagamitin lang natin is ito. Motor servo. Yan yung ating variable under servo dot attached. Ibig sabihin, i-attach natin yung servo motor natin na nakakonekta saan? Pin 2, which is our servo pin. Nakakonekta siya sa pin 2. Close quotation. Yan lang ang kailangan natin. Sir, kailangan pa ba natin i-pin mode yung A0? Hindi na rin po. Kasi yung A0 ay matic na siya ay input. So, no need. Sunod, sa void loop natin, dito na tayo magde-declare ng ating code. So, ang una natin gagawin is value. Yung variable natin na value is equal to analog read. Ang analog read, it means na kukuhanin natin yung value na tinatanggap ng isang analog pin. Sa atin, yung potentiometer natin ay nakakonekta sa A0, meaning, doon tayo kukuha ng reading. Yun ang ibig sabihin ng analog read. So, ang analog read natin na ilalagay, yung open parenthesis, ang ilalagay natin dito ay pot pin o yung potentiometer pin, which is located at A0. Sunod, si value ulit ay ating gagawa ng range. Kasi ang matatanggap na value ni servo ay isang integer from 0 to 1023. Tatandaan ninyo sa analog input, yung 0 to 5 volts na matatanggap ni analog input gamit ang potentiometer, ang reading niyan kay Arduino ay 0 to 1023. To 1023. Yun yung reading ni Arduino. Ngayon, kailangan pong gawaan ng 0 to 1023 in terms of angle na from 0 to 180 degrees ni servo. Paano natin gagawin yun? Gagamit tayo ng function na tinatawag na map. Map, value, comma, 0 to 1023. Ito yung unang value na matatanggap talaga ni value ni potentiometer. Tapos, comma, ano yung scaling value? Kung 0 ay 0 degrees, then from 1023, siya ay 180 degrees. So, ibig sabihin, yung magiging value magiging bagong value ng ating variable will be now hindi na 0 to 1023, but rather nakamap na siya from 0 to 180 na. So, ibig sabihin, mapapaikot na natin yung servo ng walang problema na siya ay papalo ng 0 to 180 by using motor servo dot write. Then, ano ang ating ilalagay dito? Yung value. Let us check. Pag in-start natin yung simulation, kung gagana yung system natin. I hope na wala siyang error. Yun na lang ating dito. Oh, walang error. So, ngayon, yung servo natin is located na at 0 degrees. Pag pinihit ko ngayon yung potentiometer ko, pansinin nyo, umiibo din yung aking motor. And as I try to turn the knob to its maximum, ito na yung maximum niyang 180 degrees. Oh, of course, nakatabingi kasi yung servo motor natin is medyo tilted yung position at 0 degrees. So, of course, pati sa 180, tilted din yan. Pero kung titingnan ninyo yung rotation niya, kung titingnan niyo yung rotation niya, once that I turn the knob, it follows the position also of the servo motor. Bago nga pala makalimutan, dapat nga pala, don't forget to put some certain delay para hindi din hirap si Arduino. Around 15 milliseconds. So, pwede mo siyang i-move. Ito yung isa sa mga project na pwede ninyong gawin sa bahay, but instead of potentiometer, pwede to. Kung may maliit kayong solar and if you want to have a effective solar light, yung effective captured ng light ng solar, then you may use what we call a light dependent resistor or yung LDR na sinasabi to see the presence of light, the amount of light na natatamaan yung solar ninyo. Then may servo sa likod na pwede niyang i-tilt once na nag-move yung araw from sunrise down to sunset. Pwede niyong gawin yun. Ang tawag natin doon is what we call sun seeker. Sun seeker. So, you use at least around 2 LDRs and 1 servo motor. para ma-check mo yung value ni LDR1 at saka LDR2 by condition, LDR1, LDR2, dapat pantay ang liwanag na natatanggap ni LDR1 at saka ni LDR2. Pag hindi pantay, paano siya magtitilt? So gagamit niyo ng servo motor para itilt. Pag nagpantay na, halos nagpantay na, then titigil yung movement ng solar ninyo. Pag mas maliwanag naman dito kaysa sa dito, titilt na ulit. No? So, ganun kaganda yung paggamit ninyo ng Arduino. If you want to have fun with servo motors, then how would you try to put servo motors on an application? So, one last activity that we have, ito, i-open ko na lang. And you have this one on your PowerPoint presentation. So, you have a guide on how would you try to create this one. Gusto ko lang ipakita sa inyo yung application ng Arduino which pertains naman to distance. Kung sino man dito yung may lumang kotse sa kanila, sa family nila, na walang pag yung nagre-reverse ka at magpa-park ka at hindi mo ramdam kung ikaw yung driver, hindi mo ramdam kung hindi ka masyadong ganong kagamay sa sasakyan mo na baka mabangga mo yung wall sa likod, you may use this particular application. You have what we call an ultrasonic sensor. An ultrasonic sensor is a distance sensor that uses sound instead of light. Kaya niya makapag-detect ng distance by using sound. Using ultrasonic sound or ultrasonic waves. Kaya yan dalawa, it means that this is receive and transmit. Ang ginagawa kasi nitong concept na to, makikita nyo din sa PowerPoint presentation, is it uses the principle of echo. And gaano katagal o yung duration ng echo within the maximum of 3 meters if I'm not mistaken. Para malaman mo yung distance based on the duration kung gaano katagal nag-travel yung sound from transmit down to receive. Ito din yung ginagamit, itong ultrasonic sensor na din ito ang ginagamit dun sa paikot na parking lot sa SM. Sa inyo makikita sa overhead ng parking lot na paikot sa SM. Makikita niyo yun, yung ang tawag ko doon, dalawang mata ni Wall-E. Ang ginagamit lang nila doon is para makadetect ng presence ng sasakyan. Itong project na to is para makadetect ng distance ng object na nadetect ng ultrasonic sensor. Ito din yung ginagamit na sensor na lane ng mga sasakyan niyo na pag na-backwards parking ka, may tumutunog habang nagbabak ka to check for any collision sa likod. Sa atin, mas maganda kasi meron na rin ata yun sa mga bagong sasakyan, may distance na. Pero kung may lumang sasakyan ka, around mga 1990s model down to around 2005 model. Hindi, 2005 model, meron na rin atang distance sensor. You could use this one as your project. Right now, it detects its distance of 107 cm. Para malaman mo kung ano yung nade-detect ng ultrasonic sensor, pwede mong i-click yung ultrasonic sensor habang nasa simulation. Then ito yung object, pwede mong i-move. As you try to move the object palayo, you would see the distance in terms of centimeters kung gaano kalapit. Ang kagandahan nito is it has a distance up until 3 meters. Or 300 centimeters. So para pag gumawa kayo ng project na ganito at inilagay mo sa sasakyan mo, testing lang, may ganitong ginawa din cases na aid din sa mga drivers, lalo na sa mga sides, collision sa mga sides. You may use the distance sensor or ultrasonic sensor sa mga backwards parking ninyo. Para habang lumalapit ka, nakikita mo ngayon kung gaano nakalapit ikaw sa wall. Para hindi mabangga yung rear bumper mo sa walling pag ikaw yung napapark sa SM. Or, kung may talikuran ka sa parking lot. Most especially if you are fond of using yung backward parking. Ano? So let us see the code for this one. So sa makikita ninyo, yung code natin dito focuses on having liquid crystal display na library. Then it has its constants. Then itong constant na to, yung trigger tsaka echo pin, this is a constant variable for your ultrasonic sensor. Trigger meaning transmit, echo means receive. Tinatanggap niyo yung echo. So yung isang mata ay nagtatransmit ng signal at yung isa namang mata, well, I call it as mata, dapat pala tenga. Ano, yung isa pala ay bibig, yung isa ay tenga. Trigger, echo. Ano? Pin 7, pin 6, magsasend siya ng sound, babounce back sa wall, then pakikinggan ni pin 7. That's why you would see on the void setup na meron kang trigger pin na output at echo pin na input. Sa void loop natin, makikita ninyo, ito yung triggering ng sound. Then, ito naman yung calculation natin for the distance. This is seen on the PowerPoint presentation kung saan nanggaling yung formula na yan. Then, ito yung pagsaset natin ng LCD screen. Ganyan kasimple. Yun nga lang, ang problema lang sa mga sa mga LCD screens nga pala, lalo na pag ang LCD screen ninyo ay yung wala yung certain type of communication, I call it as I2C or I2C. Marami siyang kinakain na pins. Marami siyang kinakain na pins. Yung LCD screen. Occupied na maraming pins dito. So there are so many projects that you would see on the PowerPoint presentation. I hope that you could browse those things. I think up until activity number 7 so that you have fun on working with it. Applicable naman siya kay Tinkercad. May isa lang doon na hindi siya applicable kay Tinkercad is because it uses a different type of protocol na wala pa kay Tinkercad. Yun sa LCD screen. Pero the rest can be used for LCD screens. Can be used as your activities. Like controlling a servo, controlling the LED of pin 13 using serial communications. Ang dami. Nandito na rin yung discussion ko. I'll give this one to ICEP, JI, and ACES, pati JPCS, so that you would have a guide on working with this. Ito yung sinasabi ko sa inyo na wala sa Tinkercad for I2C or I2C. Ito yung code for non-I2C. Ito yung ginawa natin ngayon. Ito yung example ko kanina. Ito naman po for I2C. Medyo mahaba yung Here are my references. My guides. Saan ako nagpapatibuhat? Saan pa ako pwedeng makapag-aral pa ng Arduino? Or makakatulong sa akin sa paggawa ko ng project. Lalo na to, sir, hindi ako marunong ng wiring paano ako magwa-wire ng mga components kagaya nito, kagaya niyan. Circuito.io, one of the best. Drag and drop ka lang, siya na mag-automatic na mag-create ng connection para sa inyo. Yun nga lang, wala lang sa emulation pa sa Circuito.io. Unlike with Tinkercad. Of course, Arduino.cc, that's the main web page of Arduino. If you want to create an offline design of your circuit, yun nga lang, walang sa emulation, you may also use Fritzing. Fritzing.org. Sa mga guides natin ng mga basic electricity, lalo na sa mga kasamahan natin sa JPCS, you may learn about circuit basics, how to mechatronics are some of the Arduino projects that are available that are really fun. Maghanap kayo dyan, ang daming mga masasayang projects dyan sa how to mechatronics, and even in instructables.com. I'm also there at instructables.com. I have also some instructable guides there for Arduino. Most especially linking Arduino with MATLAB. Meron din ako doon. Yun nga lang, kailangan hardware MATLAB ang gagamitin ninyo. Hardware Arduino ang gagamitin ninyo. You cannot link your Tinkercad with MATLAB yun. Marami akong guides dyan. Then some videos for you as a guide. At the end of the session, I would say, coming from Massimo Bansi's Talk with Ted, yung one of the inspirational talk conferences. Massimo Bansi, the founder of Arduino, said, "You don't need anybody's permission to create something great." Ito yung isa sa pinaka gusto kong naging line niya when he talks about how did he create the Arduino microcontroller. Muli, marami pong salamat sa mga orgs na nag-contribute nito, and also to the participants. This will also be recorded and uploaded on YouTube on my channel and on SG, if I'm not mistaken. Sa SG, ipopost nila, or sa ISEP, and the other org na kasama din dito. Muli, marami pong salamat. If you have some questions, medyo limited na yung time natin, you may try to approach me na lang on Facebook. Tap me on Facebook. Gov Allen knows my Facebook page. My Facebook, my Facebook name. Try to tap Gov Allen and the rest of the ISA community. So yun po.
See you with that.
Pero kung may questions kayo ngayon, feel free to ask na para at least I could share na rin kung anong May questions po ba? Huwag po mahiya. This is free. This is your opportunity for you to know more. Doon naman sa mga nahihiya magtanong, you could approach me through Facebook. So may questions po ba?
Sir Ops.
Yes, Marco.
Yes po sir, may send ako sa messenger.
Naku, messenger pa. Sa messenger sa Facebook?
Ako sir, buksan niyo ba?
Hindi. Open naman yung messenger ko. Wait lang.
Sir, para ma-check niyo. Kasi gumawa din ako ng sarili ko. So, hindi ko alam dito sir. Kaya, ginaya ko yung sa server niyo sir. May sinasabing error daw.
Sige. Balikan kita, Marco, when it comes to this. Medyo mataluti ito. It will take time. Maybe later. After lunch siguro.
Ay sir, si Crystal daw po. Meron daw po.
Sir, yun po bang mga programs na nasa-save sa Arduino ay nabubura? Okay, that's a good question. If you upload it on the Arduino, hindi na siya nabubura. Hindi siya nabubura. Pero pwede siyang mapalitan. Kung ang tatanungin ninyo ay kunwari, na-upload mo kay Arduino, then you try to deploy it on a system, andun na yun. Yung program na yun will stay there as long as hindi mo palitan yung program. Maganda yung tanong niya ni Mike Espina. Yun. Just the same with the industry-based microcontrollers or PLCs. They do not change as long as you are not programming again with that same microcontroller. Sige, any other questions pa po?
Sir, last na ako.
Sige, Marco.
Pag ginamit ko natin sa Arduino sa product, is it safe and reliable? For example, sa isang produkto na gawa natin, bilang mismo yung gain natin, or talagang pang-school project ng Arduino?
No. Arduino could be used even in the industry. Actually, there are some industries that are replacing Arduinos. Pero ang tatanong nyo, sir, ang siguro pwede ko maging tanong dyan is, sir, yung bang Chinese compatible boards are safe to use in the industry? Well, I would say yes. I have so many clones that up until now is still working, it's still running, and it's running fine. Ang kagandahan din nito, kung sakali mo masira, it is cheaper to replace. It is cheaper to replace. The Arduino, if you want to buy talaga na reliable, sobrang reliable talaga, nagagamitin mo talaga almost around 5 to 10 years of usability running 24/7. And if you want to be assured of yourself, then I would say you try to use an original Arduino. Yun nga lang, masyadong expensive. Ano? Pero if you're talking about 5 years of use on a cheap microcontroller, yes, I have so many Arduinos na halos ka-year level nyo na, and it's still working. Ano? No worries about that. Ano? Yun nga lang, try to find a legit seller talaga. Ano? Legit supplier for Arduinos. Most especially if you're working on an industry. So any other questions pa po? Ano? Sayang opportunity.
May tanong po.
Yes po. Go Balen.
Kung pwede daw pong gamitin si Arduino app, bigyan ng power si Arduino through power bank.
Yes. Yes. And definitely yes. I have used so many Arduinos that I tried to put it on power bank. Ito yung isang example ko. I tried to do this one last week. Around Saturday last week. Gusto ko kasi i-test yung aking ano. This one is an Arduino compatible board din. Under ESP8266. Ang gusto ko kasi i-test dito, I have around 5 of this at home. This kind. ESP8266. Kasi nga wireless siya, may Wi-Fi built-in. Gusto ko matest kasi yung network capabilities niya on its long-range scale. So, ibig sabihin, ito, kailangan kong dalhin sa labas. And i-check ko kung gaano kalayo yung range niya. So, ibig sabihin, kailangan ko itong saksakan ng supply. Ito. Kailangan ko lagyan ito ng supply. Kailangan ko ito lagyan ng supply. So, kung lalagyan ko ng supply, so I'll be showing this. So, kailangan ko lagyan nito ng supply by yung micro USB. By yung micro USB, kailangan ko lagyan nito ng supply. And the supply that I have at home para mobile ako is a power bank. I use a power bank, put it in here, run the system in, yes, it will work fine. Yung aking robot naman, on the other hand, uses a yung battery ng vape. Ano? Tapos i-connect ako sa VCC and ground ni Arduino. Meron yan nakalagay na label na VCC and ground ni Arduino. Pwede kong ikabit yon doon. Then, pwede kong buhayin ngayon yung Arduino Mega ko. Gamit naman ito. Kahit hindi ako gumagamit ng power adapter, pwede rin. So, there are many ways to supply your Arduino. Ano? Pero ang isa sa pinakamadali, kasi meron tayong power bank sa bahay, is power bank. Yes, that is true. Ano? Tama yun. Okay lang yun. Okay lang. So, kay Rolly Banaan, may possibility po ba na magamit sa Arduino as a weaponry sa military? Well, ethically, engineering side of things, yes, you could use this one on military, on a little bit of precision devices, for targeting systems. Pero ethically speaking and morally speaking, for defense purposes, yes. Yun na, ethical and defensively speaking. For defense purposes, yes, you could use this one on so many applications. Yun nga, ang nakakatakot din, ang nakakalungkot din, one story din, you would see sometimes on news na yung mga ginagawang homemade, nakakalungkot, they're using microcontrollers as for bad purposes. Alam niyo naman na technology could be used on either good or bad purposes. Pero yun nga, may mga nakikita kang gumagamit ng ganito for terrorism, kasi mas madali na siyang gamitin, mas murang gamitin, then they try to put that one on a system to bomb things. Nakakalungkot na ginagawa nila yung isang magandang technology, Ano, isang magandang technology to use it on a bad way. Ano? Pero on other side of things, military purposes or defense purposes or risk reduction purposes, ginagamit ang Arduino ng Batangas State University, if I'm not mistaken. May isang thesis ng Batangas State University to check for sulfur content ng tall volcano. May gumawa ng ganun. Meron din gumawa ng mga sensors to detect levels of earthquake, digital seismograph that it is connected online. Pwede rin yun, digital seismograph. Para mabigyan ng warning din ng mga tao, once na nakakita na ng medyo mataas na activity, they would send a signal sa head office o kahit sa barangay man lang na pag malakas yung bagyo, mabigay ng warning. Malakas pa lang din doon, mabigay na ng warning sa mga tao through text blast. Pwede rin yun. Ang daming pwedeng paggamitan ng Arduino, no? Yun yung simple na nakita ko dun sa talk ni Massimo Bansi is para malaman mo yung condition ng plant mo kung siya ba ay buhay pa, nangangailangan ng tubig o nangangailangan ng araw. Ang daming pwedeng gamitan. So many applications. You would see that so many in YouTube, ano? Lalo na yung mga hackers, mga white hackers natin or mga electronics enthusiasts that would really work on different types of projects. Siguro ang makita ko dito magandang project na nakikita ko na try to look smarter every day sa YouTube, if I'm not mistaken. Tapos meron pa yung Make Things Better na channel ng YouTube. Meron doon silang diniscuss na pag tumira ka ng basketball, hindi ka magmimintis kasi yung ring ang humahabol dun sa bola. O yung yung sa darts, kahit saan ka tumira, it will automatically hit a bullseye. I think nandun yun sa Smarter nakalimutan ko kung sino kaibigan nyo ni Smarter Everyday na channel na gumawa siya ng and it is linked to actually a MATLAB software, if I'm not mistaken, to complete the calculation for the trajectory ng dart pin o kaya ng basketball. Yung bola ng basketball. Of course, it has cameras built in. Very sophisticated na yun. But yes, they use Arduino to control the servo motors for that. Dami. Yes, that's right. Yeah, thanks Mike Espina for the inputs. Mark Rober, yes. He's the one that created yung never miss na darts. Yung sa basketball naman, ibang tao yun. But it is fun to see that you use a technology such as an Arduino to create some fun things. Yun nga lang, yun din, pampaboost din ng channel. So, it's fun to see that Arduino has gone a long way. Napakarami na talaga. I tried this one on my robot. I tried this one on my home. Pang-control ng Christmas lights before. I tried to use this one. Pagkadating ko ng bahay ng gabi, ako na magbubuhay ng Christmas lights using my phone. I tried this one at home. It was effective and it was fun. So, I think that's it. Bali, napapasalamat po ako sa lahat. And hopefully we could have some other sessions for this.